Hello! In this tutorial, I will be showing you how you can find the area of a four-sided piece of land with only 4 coordinates, which you can get from a GPS. Let me demonstrate. Imagine that you are planning to buy this piece of farmland, but before you do, you want to get an exact answer as to how big that piece of land is. It's from point 1, point 2, point 3, and point 4. First, you walk to point 1, and you're holding a GPS. The GPS should give you some coordinates, like this. Then you walk to point 2, and you write down the coordinates for that point, and you walk to point 3, and you walk to point 4. How will you find the area of that piece of land with just these 4 coordinates? You have 4 coordinates for your piece of land, point 1, point 2, and point 3 and point 4. We can use matrix to find the area of this piece of land. First, we find the area of this triangle here, so area 1. The first triangle's coordinates are P1, P2, and P3. So we put it in this matrix: x1, y1, x2, y2, and x3, y3. And on the side, each of them has a 1 here. The area of the next triangle, and the area of this triangle is the determinant of this matrix times a half. The area of the next triangle equals to a half times the determinant of the function, the determinant of the matrix. We have these 3 points, P3, P4, and P1. So x3, y3, x4, y4, x1, y1, and we have a 1 on the side here. The area of this quadrogram equals to the area of the first triangle plus the area of the second triangle. So it's this plus this. How do we find the determinant of a matrix? Let me take this matrix here and see how we can find the determinant. Over here is the matrix. I duplicate that matrix and put it right next to it like this. So these two are the same. I have these diagonal lines starting from the first element of this matrix, and over here we have these 3 tubes. The first one is the first element, second one, and third one. These times together plus these times together plus these times together, subtract. Over here I have that duplicated matrix again, only this time the lines are going the other direction, and it's starting from this side of it. We times these together, plus these times together, plus these times together. So we have this plus this plus this, subtract this plus this plus this. Now I have these numbers. Point 1 equals to 1435. And here we have these other coordinates. Let's substitute the numbers into our formula here. We get this. Now let's find the determinant. The determinant of this matrix equals, over here I put in the numbers, we get 73. The determinant of the other matrix is 169. So we plus the 2 together and divide by 2. We get 121. Now let's have a look at our Python program. First, I will run this module. Here we get the area is 121 square units, and here we have that graph. Now let's see how we can create this program. First, I import matplotlib.pyplot as plot. This is simply a shortcut to get this. Then I import numpy as np. I define this variable L This will be a list of all 4 coordinates. Now, L dot append L, the 0 index. The 0 index of L is this. I want to add this to the end of the list. So that way, when we graph it, they will graph this point connected to this point, connected to this point, connected to this point. And I want to close that quadrogram, so I connect it back to the first point. So I have to add the first coordinate to this list. X list equals to an empty list here, and Y list equals to an empty list. For every coordinate in this list of coordinates, X list dot append the 1 index of that coordinate. So the 1 index will be here, and Y list dot append the 1 index of that coordinate. So this is the 1 index of the coordinate. So after going through this loop, this X list will contain 14, 12, 19, 25, and this Y list will contain 35, 28, 16, and 27. Plt.plot X list, Y list. Plt.plot will return a graph, and here we input a list for the X coordinates, and here we put in the list for the Y coordinates. They will graph it for us. Plt.xlim, that would let us decide how big we want our graph to be. I want my graph to start from 0 for the X coordinate and end at 40, and start from 0 at the Y coordinate and end at 40. Matrix 1 equals np.array. np.array will give a, in here we can put in the matrix. The matrix is 3-dimensional for our case. So you can see here, if I put an enter, here we have the 3 dimensions. First, L, the 0 index of L is these coordinates here, but I do not want these brackets. I want to remove them. Using the star sign, we can remove the brackets. So now, this will be a list containing 14, 35, and 1. And this list will contain, let's see what's the 1 index of L. Here it's 12, 28. So with the star sign, we remove the brackets, so it's 12, comma space, 28, comma space, 1. And we do the same thing for this coordinate here. Now, let me just remove these. As you can see here, matrix 2, which is the matrix for the other triangle, we do the same thing, only that for the other triangle, we have this coordinate, and this coordinate. So we do that in that order. Area 1 equals to, area 1 is the area of the first triangle. It equals to 1/2 times, over here I have the NumPy module, numpy.linearalgebra.determinant. If we pass in the matrix here, this will return the determinant of the matrix we passed in. So 1/2 times the determinant of matrix 1, area 2 equals 1/2 times the determinant of matrix 2. The area of the quadrogram is area of the first triangle plus the area of the second triangle. Finally, we print the area is, here around the area to the nearest thousandth digit, square units. Now, we can play around with this program. For example, we want to change these coordinates a bit. I'll change this 14 into a 19. I want to change this 35 into a 45, and change this into a 16, and change this 25 into 35. Let's see what we get. I run it. Oops, it came out of our coordinates. So let me change the y limit of our coordinate. I'll change that to a 60. Oops, that's the x limit. Here I change the y limit to a 60. I'll run it. We get the area is 275.5 square units, and we get this nice graph. This is the end of this tutorial. If you have any questions, requests, suggestions, please leave them down in the comment section below. And please subscribe to my channel. I upload a new video every day. Today is January 25th, 2020. Thank you for watching and have a nice day.